The motivation behind the WSCUC absolute graduation rate, or AGR, is laudable. Accreditors and institutions of higher education should be on the lookout for means of promoting transparency, and there's plenty of room for innovation. Given the evolving educational landscape, and especially increasing numbers of transfer and part-time students, easily interpreted measures to supplement the IPED's graduation rate would be welcome. However, while the unit-based approach taken by the AGR and the unit redemption rate is creative, in practice it creates more problems than it solves, and it is problematic in ways that should preclude its use as either a substitute for or a supplement to the IPED's graduation rate. This piece considers 5 ways in which the AGR misses the mark. 4 of them are related to the calculation of the metric. One is somewhat more philosophical. For a small but non-trivial number of institutions, the AGR yields meaningless values. Estimates of the AGR require schools' enrollment to remain steady year over year, but this requirement is rarely met. In its generalized form, the AGR is independent of time. Computationally, however, it relies on disparate periods of time, and as a consequence, provides biased point estimates. The recommended fix for this bias only compounds the error in many cases. Finally, given these issues, it should be apparent that the AGR requires more explanation than any serviceable metric should. Philosophically, then, the AGR falls well short of its goal of providing an easily interpreted metric of student success. What follows is a consideration of the AGR as it applies to already accredited institutions in the WSCUC region. The 2016 institutional data provided by WSCUC for this analysis contains complete data for 151 accredited institutions. 6 of these schools reported either 0 undergraduate units redeemed or 0 units taken by students who dropped during the previous year. In the former case, the AGR resolves to 0. In the latter, it resolves to an undefined quantity. This leaves 145 institutions for analysis. Unlike conventional headcount-based graduation rates, the AGR formula can produce single-year point estimates that are logically out of range, that is, more than 100% or less than 0%. Of the 145 schools available for analysis in 2016, 7 have values in excess of 100% and 3 have values less than 0%. Some may question the utility of a metric that produces values that are out of range. One of the ostensible goals of the AGR is to provide stakeholders with an easily interpreted metric. The fact that 7% of schools have values that are off the charts should give pause. What simple explanation is there for a graduation rate that is higher than 100%? More students graduated than began? Or graduation rates that are less than 0%? Did some non-graduates have to return their diplomas? An appendix of the AGR white paper demonstrates that its unit-based approach yields estimates equivalent to headcount-based rates when taken over the life of an institution. For shorter periods, that is, any period shorter than that, valid estimates require that a school's enrollment remain steady, neither increasing nor decreasing. This is an important caveat and a frequent refrain of the white paper. The only guidance that the white paper offers as to what constitutes steady-state enrollment is found in its examples. In each of these, units attributed to graduating, continuing, and dropped students are uniform year after year, with absolutely no variation. If the steady-state requirement can only be met by institutions with an identical allocation of units from year to year, the AGR isn't a valid measure for any institutions in the sample. Clearly, a threshold higher than 0 is required. In the absence of an accepted threshold, we look to the data for a reasonable cutoff. The greatest variation in the variables that contribute to the AGR formula is in the so-called unredeemed units, those taken by non-graduating students during the reporting year, so that is where we turn our attention. You can see the effects of variations in enrollment on the AGR when the formula is adjusted to compensate for increases or decreases in these units from one year to the next. The adjustment is computed by subtracting the prior year's unredeemed units from the reporting year's unredeemed units. If an institution has increased in enrollment, the difference in units will be positive. Subtracting these difference units from the reporting year's unredeemed units will make the equation's denominator smaller in most cases, thereby increasing the AGR. If the institution has decreased in enrollment, the difference will be negative, and subtracting the difference units will make the denominator larger, thereby decreasing the AGR. The following 2 graphs illustrate the effect of this adjustment and the relationship between changes in enrollment and the AGR. This first graph shows institutions that experienced declines in enrollment between the 2015 and 2016 reporting years. Schools are arranged by percent decrease in unredeemed units, largest to smallest from left to right. The percentage decrease in unredeemed units is highlighted by the boundary of the shaded area, which ranges from 0 at the top to 30% at the bottom. The lines on the graph show two AGR values for each school. The reported AGR is shown as a leftward pointing tick. The adjusted AGR is shown as a rightward pointing tick. For schools with declining enrollments, the reported AGR is at the top and the adjusted AGR is at the bottom. So, for example, this school experienced an 11% decline in unredeemed units, which has the effect of inflating its AGR to 90%. Adjusting the unredeemed units results in an AGR of 72%. This better reflects actual enrollment patterns at the school. We know this because the D term of the equation increased by 12% between 2015 and 2016, and because the ratio of drop to enrolled units grew nearly threefold between these 2 years. The same adjustment, when applied to institutions that are increasing in enrolled units, has the effect of raising the AGR. This school, for example, experienced a 13% increase in unredeemed units from 2015 to 2016, which drove its AGR down to 65%. The adjustment raises the AGR to 84%, which, again, is a better reflection of what is actually happening at the school than the reported AGR might otherwise indicate. You may be thinking at this point, if the adjustment compensates for changes in enrollment, why not just incorporate it into the formula? One answer to this question is that there is a small number of schools for which the adjustment does not bring the AGR into range. If the goal is a metric that can be used across all institutions, this adjustment, while illustrative, falls shy of being a solution. This exercise suggests that changes in enrolled units are approximately inversely proportional to changes in the AGR. That is, a 5% increase in enrolled units results in a similar decrease in the AGR on average. While an institution might tolerate 1 or 2 percentage points of error, 4 to 7 percentage points might be harder to swallow. This suggests the adoption of a 5% threshold. That is, schools with year-over-year differences in unredeemed units in excess of plus or minus 5% cannot be considered to be in a steady state. If we limit our comparison of unredeemed units to 2 years, 2015 and 2016, and use a 5% threshold, 49.7% of schools could be considered to be in a steady state. This means that the AGR would not be considered a valid measure for the remaining 50.3%, just over half of the institutions in the sample. The AGR calculation relies on units, but if we applied the same threshold to headcount, the percentage considered to be steady state is nearly the same, at 51%. If an even more conservative threshold of 2% were applied, only 1/5 of schools would be in a steady state by units, and just over a quarter would be steady state by headcount. If, instead of relying only on adjacent years, we compare the maximum to the minimum enrolled units for the period from 2010 to 2016, the proportion of schools that could be considered to be steady state still hovers around the 50% mark. Here's a quick look at the year-over-year headcount and accompanying AGR for the 145 institutions in the sample over the period between 2010 and 2016 or 17. How many of these schools seem to be in a steady state? A good deal is made of the AGR being free from the constraints of time in comparison to, say, the 6-year graduation rate. Unfortunately, single-year point estimates of the AGR are computed by cobbling together values from different time periods. So-called redeemed units are those taken by students graduating in the reporting year, but the majority of these units have been in the pipeline for a few years. Unredeemed units are those taken by non-graduating students during the reporting year. The proportion of the formula's denominator that standardizes surplus, that is, unredeemed minus redeemed, units, refers to units taken by students who dropped sometime during the year prior to the reporting year. So, the measure is a set of interacting proportions, but the various parts of these proportions refer to different periods of time. For most of his life, my dad kept a notebook in the glove compartment of his truck. In it, he kept a log of his mileage and the amount of gas he put in his vehicle, with which he regularly computed fuel efficiency, MPG. If he noticed a decline, he would spend a Saturday morning giving his truck a tune-up, which not only made his truck run better, but also excused him from some of the chores my mother had lined up for him. This was back when cars and trucks still had carburetors and distributors, which shows how old I am. Now, imagine what would happen if the observations somehow got jumbled, so the gallons purchased were no longer associated with the miles driven immediately prior to purchase. The point estimates of fuel efficiency would behave like a random variable. Over the life of the truck, if you were to divide the miles on the odometer by all the gas he bought over the years, you'd get the absolute MPG. But short-term estimates using the jumbled data would miss the mark. The AGR suffers from the same sort of time displacement. Yes, over the life of an institution, it all comes out okay, but stakeholders probably don't care what the 150-year graduation rate is for an institution. There's an old joke about two statisticians who go duck hunting. Seeing a duck flying by, one shoots above it, the other shoots below it, and together they exclaim, "We hit it," because of course, on average, they did. It's entirely appropriate to use averages while describing a sample of observations. It's problematic, however, to use averaging to summarize dubious estimations. Many of the institutions in the sample have seen increases in their enrollments year over year from 2010 to the present. As has been demonstrated, each increase in enrollment is accompanied by an artificial decrease in the AGR. The first AGR computed then is artificially low. Each successive year's calculation will be lower still. The result of averaging a set of biased, inaccurate computations is an average wrong number. You don't get a number that corrects for growth. The same basic problem occurs with schools in crisis. The AGR, averaged over the period, for a school that's essentially shutting down, is likely to be 100% or higher, so while the metric you're communicating to stakeholders seems to indicate that no units will go to waste, in fact, the school may be in danger of closing before the tuition check clears the bank. The issues described above are well known by the intrepid WSCUC staff, who have had to answer questions at the ARC and in other settings. When finding themselves in this uncomfortable circumstance, they're reduced to saying things like, "There's not a good AGR or a bad AGR, there's only your AGR," and "Use the AGR to tell your story." What does that story sound like exactly?
Here's our terrible score on this WSCUC-endorsed metric.
As parents' eyes begin to glaze over, the admissions counselor continues.
See, the denominator is sensitive to the changes in the units taken by students who did not graduate during the reporting year. So even though our scores look bad, that's due to an issue with the way the metric is calculated and has very little to do with how your son or daughter is likely to fare at our institution.
Schools shouldn't be put in the position of having to explain why this official metric misses the mark. Their time is better spent telling their actual story. The WSCUC staff shouldn't be put in the position of having to tell university administrators that they need to come up with an explanation to justify their score. Visiting teams shouldn't be put in the position of needing to console successful schools over their terrible AGRs. In order for a metric to be useful, scores should have consistent, easily intuited meanings. For a graduation rate, if University X's score is higher than University Y's score, we expect that a larger proportion of University X's students graduate. This is clearly not a claim that anyone can make about the AGR. Instead, a school with declining enrollment can have a higher AGR than a school of the same size with the same dropout characteristics, but which did not experience a decline in enrollment. This is true both of point estimates and when averaging over longer periods of time. In order to promote transparency, WSCUC should continue to require schools to make pertinent data available to stakeholders through the usual channels. But WSCUC should also recognize that one size won't ever fit all, and while the desire for a standardized metric like the AGR is understandable, it ignores the diversity of schools under its watch. Diversity gives WSCUC its distinctive flavor. There is no one metric to rule them all. In my sector of the educational landscape, programmatic accreditors hold schools and their programs to very high standards. In recent years, WSCUC has expressed interest in reducing redundancy in reporting for institutions whose programs are subject to programmatic accreditors' scrutiny. This would be a good starting place for reducing redundancy. It should be sufficient for schools to report the metrics associated with the standards to which they are being held by programmatic accreditors. Schools with relatively few programmatically accredited offerings can still be required to publish information that is useful to parents, potential students, and other stakeholders using established, meaningful metrics, like those recommended by the Common Data Set. With the wide availability of business intelligence dashboards, It is easier than ever for schools to make a great deal of information about their degrees and majors available. By focusing on the AGR and unit redemption rate, the WSCUC website makes it seem as if a student's likelihood of success can be boiled down to these two metrics, but the quest for more transparency requires more information, not less. Is your school's 150% graduation rate lackluster due to a high proportion of part-time students? Supplement it with an indication of how many students in that cohort were part-time for at least some of their journey. Are there too few students in some categories to make reporting meaningful? That's where asterisks and some explanatory text comes in. But don't make institutions report a metric that misses the mark and then require them to explain the idiosyncrasies of the metric to stakeholders. If anything, rather than enhancing transparency, that just makes the whole enterprise more opaque.